All right, so ideas for what you think is going to be on today's test, call them out and I'll add them in. And if somebody calls out something that you're like, wait, what? Make sure you ask what we're talking about. Call it out. What do you think is on today's test? Okay, so we've got the angle sum theorem. And you need to make sure that you know that's the one where you know that the angles in a triangle add up to 180 degrees. Keep going, next. Okay, there are hinge theorem. Hinge theorem is the one that says that if you have two triangles that have the same side lengths, this guy and this guy, this guy and this guy, that if the one angle is bigger than the other angle, then its triangle side is going to be bigger than the other triangle side. That's the one that my sweet Caroline affectionately called the duh theorem. Any others? Come on, call them out. Okay, you're going to definitely need to know what the hypotenuse of a right triangle is. So when we talk about a right triangle, regardless of how it's oriented, once you find that right angle, that hypotenuse is going to be the side opposite, and that's going to be your longest side. Call it out. What else is on the test? Definitely your Pythagorean theorem. So your Pythagorean theorem has an idea of a squared plus b squared is equal to c squared. And then the converse that says if that's true, then you have a right triangle. And then don't forget about your inequality that talks about what happens if c squared is bigger, what happens if c squared is smaller. And you need to know what kind of triangle results if that's the case. What else is on test? Call it out. The exterior angle theorem. Do you know what an exterior angle is? When we talk about our exterior angle theorem, draw yourself a picture. If I have a triangle, if I extend that one side, this is my exterior angle. And I know that he's going to be equal to the sum of the other two. So if I call this angle 1, angle 2, and angle 3, I know that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3. What else? Call it out. Yeah, your corollary. And that one goes with this triangle sum theorem. This is our corollary. C-O-R-O-K. And the corollary of the extra triangle theorem or triangle sum theorem has to do with these right angles. And these right angles says if you have a right angle, then I know that the measure of angle A plus the measure of angle B is 90 degrees. I don't have to worry about the 180. What else is on the test? A few simplifying radicals, but when you do it, I want to make sure that you understand there's a difference between an exact value, which is where you're simplifying radicals, and what do these lines mean? What do they mean? Approximate, yeah. Go ahead, take it out to the nearest hundredth, which means you go 3 decimal places out, and then if it's 5, 6, 7, 8, or 9, you can round up. Okay? Anything else? Go ahead. Yeah, oh my gosh, we've got lots of vocabulary. When we talk about sides, there's 1, 2, 3 words. When we talk about angles, there's 1, 2, 3 words. Can you think about those words in your head right now? Sides. No sides congruent, what's it called? 2 sides congruent, what's it called? 3 sides congruent, what's it called? All right, let's talk about angles. If I have 3 of the same type of angle, 3 acute angles, what is it? Okay, 3 is equal angular. What if all 3 angles are not the same, but they're all less than 90 degrees? Acute. What if I have one angle equal to 90 degrees? What if I have one angle larger? What if I have 2 angles larger than 90? That's not a triangle. That's not a triangle. Which brings in those inequality ideas. When we talk about, this is a big one, the sum of the two sides of a triangle has to be what? Bigger than our third side, always, right? Anything else you can think of that you need? Okay, when we're talking about the hypotenuse, we can also talk about the idea of these legs. What about our isosceles base angle theorem? What does this one say? What does this one say, Hansel? What's it say? Yeah, if these two sides are congruent, then these two angles are congruent. If these two angles are congruent, then the sides are congruent. All right, let's take a peek at the review packet. Kind of go through that fast. Anybody have any questions on these pictures? Anything you want to talk about, further explain, you couldn't get, you want to go over? Everything good? All right, how about these sometimes, always, nevers? How you feeling about them? Anybody want to ask anything about them? All right. How about this side? Classifying. Right scalene. Obtuse isosceles. Equilateral, equiangular. Find the measures. Any questions there? Did anybody in this class watch the video? Did you catch my mistake? Oh my gosh, I have some kind of issue with this problem. It's crazy because I made the mistake on my old key and fixed it. And while I was doing this, I made the same mistake and I went back and double checked it. And I'm like, no, I think I'm wrong. And I was wrong that I wasn't wrong. I was right. It was very confusing. Do you guys ever just have a hang up for something? This is fixed and it's right now. So Madison, you can put Smarty up for finding the other mistake. Hey, these problems in number 7 were hard. Did you have a hard time with them? Some of them were pretty challenging, mostly because they were hard to read. Because of the print was fuzzy. That was a bummer. Sorry about that. Anybody want to ask me any questions on these? Now, D and E, if you watch the video on D and E, you saw that I actually did the work on a Post-it note. I did not have enough room. I hate crowded math. So there's the Post-it notes for D and E. I hate crowded math. I think that you need to be able to see it. Anybody want to talk about any of these? Go ahead. You want to talk about D? All right. So when I look at D and I go to start, my first step is looking here at this is an isosceles triangle. So Philip, because this is an isosceles triangle, I know that if this is 5x minus 10, so must this one, right? But this one is given to me as 3x minus 10, so that's what sets up my first equation to solve for x. So because this angle is equal to this angle, I can set these two expressions equal to each other and solve for my value for x. Does that make sense? Once I get a value for x of 10, I can go ahead and say this is 50 minus 10, which is 40. This is 30 plus 10. So I can go ahead and call these angles 40. Once I know this is 40 and this is 40, I've got this one being 100. Because this triangle is isosceles, if this is 4y, so is this. So that means that this 4y plus 100 is going to be 180, and that gives me y is equal to 20. Does that make sense now, Philip? Okay. Anything else anybody wants to talk about? Go ahead. F? Okay. So when I look at F, this one asks us to take, to really use some transitive property of congruence and equality because I want you to follow this carefully. These two are isosceles. Both these triangles are isosceles, but not the same. So this angle is equal to this angle because this side is equal to this side. Those are my pink angles, right? Here's my purple triangle. This side is congruent to this side, which means this angle is equal to this angle. So I've got an isosceles triangle, and both those angles, I don't know what they are. They're different sizes. But then I look at each of their third angles. Check it out. Their third angles are congruent. So if I know this plus this equals 180, then I know this plus this equals 180, right? And if these are the same, that means that these angles have to be the same. Are you with me on that leap? So once I have that conversation, I can set 2x minus 25 equal to x plus 5. I can get a value for 30 for x, meaning this is a 35-degree angle. Guess what? So is this and this and this. They're all 35-degree angles. Does everybody get that? Go ahead. Keep on talking to him. What is it that you're still not clear on? How to solve which one? Can you show him, Preston? Keep going till he gets it. Go ahead.
Will you go over E?
E? Yeah. Sure. All right, so here's E's post-it. All right. Because I know that this is isosceles, I know that these two angles have to be equal to each other, but I can't set them equal to each other because I've got 2x plus 11 is equal to y. That's not going to help me. But I do have this up here. So I can say that twice this angle, 2x plus 11. Oh, and by the way, y is down in here. Y is not this angle, y is this angle. So that means that this side here is also 2x plus 11. So 2x plus 11 plus 2x plus 11 plus x minus 2 has to equal 180. So then when I distribute my 2, 4x plus 22, combine like terms, 4x plus x is 5x, 22 negative 2x is 20. Then I go ahead and get a value of 32 for x. Once I know that x is equal to 32, that helps me fill in these values, but that doesn't help me down here. So this conversation in this little triangle is actually completely separate than this upper triangle. I'm just going to do the same thing. 142 plus y is equal to 180. So solving this lower triangle has nothing to do with this upper one. They're just two separate ideas.
Yeah, I just thought the Y was in the big triangle.
Yeah, and it's funny, I did too, and that's part of the fuzzy diagram, sorry. If you're taking the test and you have any doubts about what goes where, just ask. I'll be sure to clarify whatever you need. Did you get it? Thumbs up. Thank you, Preston, for explaining it to him and put a smarty up. I appreciate your help. Are we good on this page? I thought those 6 were tricky because they involved a couple variables, lots of isosceles. I hope you plowed through. All right, next up on the review. This side looks so much simpler compared to that last one. List the sides and angles in order. No problems there. Using the hinge theorem. And this is an interesting one. We can start talking about things being equal. Our next unit is on congruent triangles, and this actually supports one of our congruent triangles. That hinge theorem is going to come back. So because they share this side, and I should probably add another tick mark to this one, because this side they each share and this side they each share, because they have equal angles, their opposite ones are going to be congruent. All right. when we take a look at this bottom part, I'm going to add the two smaller sides. First thing I do, which one's the bigger side? Step 1, who's the biggest? All right, got it. Step 2, add the smaller ones to see if they're bigger than the biggest. And truly, this is tons of fun because as soon as you find this one and this one, you're like, sweet, I don't have to do that work now because it's not a triangle. So you're like, come on, don't let it be a triangle. So step 1, find the largest side. Step 2, is it a triangle? Step 3, with the ones that are triangles, put it through Pythagoras. And I'm telling you, the number one thing that makes the biggest difference for me is having c squared being compared to a squared and b squared. If I have c squared on this side and I'm looking at, is it bigger, is it smaller, or is it equal? That is what's going to help me figure out what kind of triangle I'm looking for. If c squared is bigger, it's obtuse. C squared is equal, it's right. C squared smaller, it's acute. Questions on that? Go.
So why wouldn't C be a triangle?
C is not a triangle because the sum of my two smaller sides is not bigger than that, right? So when I simplify the square root of 74, it's about 8.6, and 3 plus 5 is equal to 8, which means that if my elbows to elbows was the base of the triangle, these ones don't meet. They're not long enough. They don't make a triangle. Go.
So for the two small things, when you add them together, they have to be bigger than the largest
They
side,
have to be bigger or else it's not a triangle.
not equal to.
So 5 plus 3 has to be bigger than the square root of 74. And here's your equal to. 4 plus 4 has to be bigger than 8. If it's equal to 8, I don't have a triangle, right? If it's equal to 8, we can go back to what we did with our sticks, remember? It's not a triangle. If it's equal, it's got to be bigger. What else you got? For number 13, classify acute, right, obtuse. Putting that again through Pythagoras. And again, I'm always going to put my C on this side. So if C is bigger, it's obtuse. If C is equal to, it's right. If C is smaller, it's acute. Go.
How do you solve for the 10 to the square root?
How do I solve for which one? For the second one?
Yeah.
Okay. So when I have my numbers inside the radical signs, let's go ahead and solve it on a Post-it. Ready? I need to know, first of all, I know that this is my largest one. 10 square roots of 3 has got to be bigger than 8, has got to be bigger than 6. Are you okay with that? So I'm going to test to see if 10 square roots of 3 squared, I'm going to look at that relationship between 6 square roots of 3 squared plus 8 square roots of 3 squared. So there's a couple ways to think about this. One of the kids in my other classes, he's like, I just put this back in the radical. So 10 squared is 100, which meant this used to be the square root of 300, 100 times 3. And then he says, because I'm squaring it, this square and this radical are just going to make this 300. Do you follow his philosophy? Okay. The other approach is using your calculator. Go ahead and type in parenthesis 10 square root 3, arrow out parenthesis to the second power. You have to make sure that you're getting all those things and you'll end up with 300. That's fine. The next approach is 10 times 10 is 100. Root 3 times the square root of 3 is equal to 3. 10 times 3 is 300. So whatever way makes sense to you, that's what we need to do. So you're comparing that to, if I follow this logic, 6 goes back in as 36. 36 times 3. So this is going to be equal to 108. And I have the square root of that squared, so that's 108. If I have 8 roots of 3, 8 times 8 is 64. Root 3 times root 3 is 3, so 64 times 3 is 192. So is your question about how I get these values?
Yeah.
Does that answer it?
Yeah.
So you have a bunch of different choices. Are you a calculator person where you type it in? Because if you are, if I'm doing 8 roots of 3, I need to make sure that I'm doing parentheses, 8 square root of 3. Then I have to arrow out. This button here takes me out from underneath the radical sign, close the parentheses, because what that's going to do is it's going to take 8 times 8, root 3 times root 3. That's where I get the 192. And when I add that to 108, I get 300, which means these are equal. Any other questions? Practice it on the calculator. Make sure you know how to do it. Right? You can't watch math, you got to do math. No watching. No passive players. No, it's fine. I'm just going to watch. You can't say no thank you. Either you know what buttons to press or you don't. All right. Would you please, can I have one group member